Hi there. So in this video, we're going to do module 55, which is all about costs. And one thing to think about with this is that some of this can get a little technical. And what I would encourage you to do, in all seriousness, is spend a little time reading this material, right? This is maybe a 30-minute read. Sit down, headphones in, something to distraction-free environment to just read through this module about firm costs, because it can get a little technical, and I don't want you to feel overwhelmed if you haven't really kind of processed what it's all about first. So I do encourage you to just spend some time, read through it. Half an hour will do you a lot of good. I also have the calculator up over here because this first problem requires the use of a calculator. On an exam, you will not have any problems that require the use of a calculator. So don't sweat it. If you start to feel like, oh my gosh, this is overwhelming, on a test, you're not going to need a calculator. On a quiz, you won't need a calculator. This is really more like proof of concept to show you that this is true, even in data sets where the numbers don't come out really nice and clean. Okay, so I've said that. That's my fair warning. Check your understanding. Number one has three parts, and there's a lot of little moving parts in number one. It says Alicia's Apple Pies is a roadside business. She has to pay $9 in rent each day. So we know that that's the fixed cost because it's just fixed. She has to pay it no matter what. And then it says, in addition, it costs her $1 to produce the first pie, and each subsequent pie costs 50% more. And so that's going to be the additional costs of production. That's her variable costs in another way to think about it. For example, the second pie costs $1.50 and so on. Calculate marginal cost, variable cost, AFC, AVC, and ATC as your daily pie output goes from 0 to 6. So we're going to need quantity of output, and that's the 0 to 6. 1, 2, 3, 4, 5, 6. Now, the first thing that it asks us to calculate is marginal cost. Now, it doesn't ask us to calculate something called total cost, which we could do, and it actually might help to do this, but in the sake of time here, I'm just going to do what it asks us to do. The first one is marginal cost. Now, for the 0th unit of output, there is no marginal cost associated with that unit, so we just put 0. Now, we know the first pie's additional cost is $1. The second pie it actually also gives us is $1.50. And then the third pie is 50% more than that. So we can say, 1.5 times 1.5, because it's including the 100% cost, right? And so it should be $2.25. So that's 50% larger than 150. Now we're going to say times 1.5 again, because again, it's 150%, because that's the number we really want. And that's 338 for the fourth pie. Times 1.5 is 506. $5.06 is her marginal cost of the fifth pie. And the sixth pie, the marginal cost is $7.59. $7.59. If only we were done right here. Now, the second part says variable cost. Now, this one's actually not as scary as it might seem. Variable cost is just thinking about, well, the fixed cost is 9. The only other cost she has is the cost of making the pies. So the variable cost, or the total amount of variable cost, you can put here TVC just for clarity's sake, is 0 for the 0th pie because she's not making any pies. But for the first pie, when she makes that first pie, now she's got a little variable cost, and it's $1. Well, the second pie that she makes, it costs her $1.50 to make that pie, but she also already made the first pie as well. So now her total variable cost is adding those two numbers together, $1 and $1.50, which is $2.50. And then we just keep going by adding the number on top of it. So we would say 225 plus 250 is 475 plus 338. I am not going to try to do that in my head. 338 plus 475 equals 813. Plus 506, well, I can do that in my head, 1319. And then this last one I am going to get lazy on as well, 1319 plus 759 is 2078. Okay. Now, the next thing just says average fixed cost, average variable cost, average total cost. So the average fixed cost is actually pretty straightforward. If we know the definition here is just the fixed cost, the total fixed cost divided by the quantity of output. And what's the total fixed cost? Well, 9, right? We know that fixed cost equals 9 because they tell us the rent is $9. So 9 divided by 0 is not a number, so we won't have a value for the first one, but 9 divided by 1 is 9. 9 over 2 is $4.50. 9 over 3 is $3. 9 over 4 is $2.25. 9 over 5, I should be able to do that in my head, but I can't. 1.8, so $1.80. And 9 over 6 is 1.5. That's really embarrassing. I just had to do that on my calculator. Now we notice AFC is just downward sloping, right? It starts really high, and then it goes get really, really small. And if we were to continue to make pies, this number would actually get smaller and smaller, infinitesimally small, but it would still exist. It would become an asymptote at the x-axis. Okay, now let's do average variable cost. An average variable cost is this total variable cost divided by the quantity of output. So the average ones all operate the same way. And by the way, we'll just do, the next one says average total cost. Average total cost, this is the total cost divided by the quantity of output. Now there's actually two ways we can do average total cost. I'll show you the second way when we get there. But let's first do average variable cost. So the next one is, right, total variable cost of 1 divided by 1. That's pretty straightforward. There isn't a value for that 0th unit. 1. And now 250 over 2 is 225. 475 over 3 divided by 3 is $1.58. And then we've got 813 over 4. Whoops, 813 divided by 4 is 203. And so we notice it started, and then right, it starts a little bit here, and then it immediately. Oh, that's a mistake. I did 250 over 2. It should be 125. Good thing I'm going slower here. Oh my gosh, did I screw that other one up too? 475. No, I did that one right, and then that one's right. Okay, so this is 125. Don't tell anybody. All right, now this is, I should slow down. 1319 divided by 1319 divided by 5, 264. 264. And 2078 divided by 6 is 346. Okay, now we'll do the last one, which is average total cost. It's the total cost divided by the quantity of output. Now, we don't have a column for total cost here. That's an issue that right, we kind of have this problem. We don't have a total cost column, but there's a second way that we can actually very quickly ascertain what the ATC is, because we know that fixed cost plus variable cost equals the total cost. We know that that's true. We would also say, if you just divide by this quantity value for each of them, that's the average fixed cost, that's the average variable cost, and that's the average total cost. And so if you add these values, the AFC and the AVC, you will get the ATC, because you're dividing by that quantity of output each time. So we can use this to our advantage since we've already calculated these two columns. So we don't have a value here, but for the first one, the average total cost is 10. That's the average total cost of making 1 unit, 1 pie. And in this case, most of it is the average fixed cost, but a small portion is the average variable. For the next pie, right, we look at it and we say 450 of that was coming for the second pie, right? And then $1.25 was coming from the variable cost side, so it's 575. Okay. Then for the next one, it's 458. So I'm literally just adding these two columns together. And then for the next one, it's 428. And then let's do this, because otherwise I'm sure I'll make a mistake. 180 plus 264 is 444. So notice it bottomed out, it came down, and it starts to come back up again. Okay. And then the last one is $1.50 and 346. So that's $4.96. So it's going to keep coming back up. It's going to make that nice U shape. Okay. Now it's asking us, we've finished with part A. Whew, right? Oh my goodness. Part B says, indicate the range of pies for which the spreading effect dominates, the range for which the diminishing returns effect dominates. And this one is talking about the idea of like the average total cost. And so kind of in this range, right, where are we spreading out the cost over more and more units and therefore bringing the average cost down? And where do the diminishing returns costs start to catch up with them? And again, if this is not making a whole lot of sense to you, go back and read this module. It's really that important. But we can look at this ATC and we can say from Q0 to Q, and where does it bottom out? It bottoms out at unit 4, the spreading effect. And that's because it's spreading out the cost over more and more units, and so it's bringing that average cost down. But at a certain point, the diminishing marginal returns catches in. You've used up all the benefits of specialization, and now it's just going to get more and more and more expensive on a per unit basis. And so we'd say from Q4, really it's more like from Q4 onward, the diminishing effect dominates, because it's actually like it hits its minimum at that 4th unit. So we would say that that's where it kind of divides the two. Letter C, what's Alicia's minimum cost output? Explain why, explain why making one more pie lowers the ATC when output is lower than minimum cost. Similarly, explain why making one more pie raises the ATC when output is greater than the minimum cost. So her minimum cost output is that unit 4, Q4, and we would say that making one more lowers it when ATC is when output is lower than the minimum cost. Making one more lowers ATC because the one way to think about it would be as saying that that we are looking at a scenario where the AVC, because AVC, or actually the best way to explain this would actually be with just marginal cost, because the marginal cost is less than the ATC in that first scenario, right? So if you're below that quantity 4, so if you're in these pies, pi 1, pi 2, pi 3, these units, 1, 150, 225, they're lower than the overall average. So adding one more pie, if it costs, for example, going from 1 to 2, costs you $1.50. And so that's going to bring this average down from 10 to 575. And that's because the marginal cost is less than the ATC. On the other hand, also, Q5 to Q6, MC is greater than ATC, so ATC rises. So it's kind of the idea of saying, hey, once you've gotten into this range, right, especially pi 5 and pi 6, you can say 506, well, that's bigger than the average, so it's going to bring the average up. And the book has this nice example of your GPA, right? Think about if your GPA is 3.0 and you take a physics class and you do really well, and that additional grade point average point is 4, well, it's going to bring your overall GPA, the grade point average, up. It's going to bring it from a 3 maybe to a 3.25. And so that marginal unit is going to affect the overall average. Okay, let's take a look at the multiple choice problems. Number 1 says when a firm is producing 0 output, total cost is fixed cost, so it's C. Number 2, which of the following is true? Marginal cost is the change in total cost generated by one additional unit of output. That's true, sure. Marginal cost is the change in variable cost generated by an additional unit of output. That's also true. And we can actually look up here and we can say, you know, what's the change in variable cost going from unit 1 to unit 2? Well, it's $1.50. That's the marginal cost. So we would say that that second statement is also true. The marginal cost curve must cross the minimum of the ATC. That is also true. And if we were to graph out all those points in a graph, you would be able to see that that marginal cost curve goes right through the minimum point of the ATC. So all 3 of those statements, that would be E. Number 3 says, which of the following is correct? AVC is the change in total cost generated by an additional unit of output. Now, a change is not going to be an average, right? A change is not that sort of thing. Notice that up here, these are just totals divided by quantities. Changes are going to be the marginals. So statement A is not correct. B, marginal cost is total cost over quantity. That's not correct. Marginal cost should be a change, right? That's TC over Q is just average total cost. C, the average cost curves cross at the minimum of the marginal cost curve. That's not correct. That's flipped around. The marginal cost goes through the minimum of the average cost curve, of the average total cost. The AFC curve slopes upward. No, it doesn't, right? We can look here and say AFC is downward sloping. So that leaves us just with the last statement, AVC equals ETC minus AFC. And if we think about, we do some algebra with this, we could find that statement E is true. Number 4, the slope of the total cost curve is the marginal cost curve. So that's pretty straightforward, E. And number 5, and the basis of the data, what is the marginal cost of the third unit of output? So it's the change in total cost of moving from 2 to 3. So 130 minus 90 is 40A. Okay, let's hope this free response number 2 is nice and short, because this is a doozy of a problem set. Draw a correctly labeled graph showing a firm with an upward sloping MC and a typically shaped ATC, AVC, AFC. Oh, that's nice and easy. I like that one. All right, we're going to make it nice and big. And we have quantity, and that's quantity of output. And we have price, and we have a marginal cost curve that does one of those. It's that Nike swoosh. And then we should have a high AFC, and then it's going to do one of those, AFC. It's going to be start high, go low. And then we'll say the average variable does one of these. And the average, and this is not to scale, average total does one of these. And so we notice that the ATC and the AVC, they both hit those minimums, right? That's the minimum AVC, and that's the minimum ATC right there. And that this curve, the AFC, doesn't normally get drawn because it's really not actually that valuable for us. Okay, hopefully this helped you. I'll see you next time.